Welcome to my video lesson on workshop practices. Workshop practices are practices that are deployed in the mechanical workshop in order to produce basic parts, little parts that one can produce on the bench without necessarily taking them to the machines. Though there are some of these processes or practices that could be carried out on the machine. But for the purpose of this lesson, I want to be discussing some bench practices, some fitting works that are available in a typical mechanical or fitting workshop. And one of these practices is the metal cutting. In metal cutting, and we're looking at the most commonest one among them, which is sawing. There are other practices that are available in the workshop for cutting processes. I can chisel, I can punch, I can equally use some other tools to cut metal. But for the purpose of this lesson, we want to restrict ourselves to sawing process. Sawing process is a process of removing surplus metal with the use of a simple tool that is called hacksaw. Whenever surplus metal or surplus material, because it is not only metal that we can saw some other materials like plastic, wood, rubber, aluminum, and and all the rest. But we are limiting ourselves to making use of hacksaw to cutting metals in this discussion. The process of hacksawing material is a process of removing surplus material through the help of hacksaw. And this hacksaw that we are talking of is not a powered saw, because we have powered hacksaw. Powered hacksaw is the one that is being powered through the use of electric motor. It is electrically powered, but this one we are discussing today is a hand tool, unpowered tool, hacksaw. A typical hacksaw is what I'm holding. A typical hacksaw has a handle. It equally has a frame. And there's a gap where I can fix my blade. The blade is the one that is doing the job of cutting in a typical hacksaw. The blade is the one that is doing the metal remover. Is the one that is actually cutting. And of course, on the hacksaw, I have another part that is called the wing nut. Why wing? Because of the configuration of the nut. It is called the wing nut. So, making use of hacksaw to cut metal requires some techniques. And these techniques must be properly followed, because the blade in itself have different types. And if one mistakenly selects a wrong type of blade for a particular job, one might not be able to get the desired results from that process. Hacksaw that is performing the work of cutting must actually be properly fitted. The right tension must be achieved from that particular hacksaw. How do I get the required size of the blade that is needed for this? I must consider the distance between this joining point and the distance between this joining point. That one gives me the length of the blade that is allowed here. I said, making use of hacksaw requires some techniques. To use the hacksaw, I must know that this hacksaw must be just a little bit above my abdomen, a little bit above my waist, because the kind of stress or the kind of force I'm going to apply on the hacksaw must be the type that will not create unnecessary strain on my shoulder. The axle must not be too low and it must not be too high. I must balance it at a particular convenient position that can guarantee free stroke of the cutting. Considering the height of my vise, where I must have clamped the work, as illustrated in the slide, in my slide. So, this particular man doing the cutting has already positioned himself, holding the handle with the right hand, while the left hand is used to support. The left hand is not imparting any force on the axle. It is the right hand that is actually providing the push force from the back. And that is giving the front stroke, the forward stroke that is doing the cutting. So it is the forward stroke of the axle that does the cutting, while the backward stroke only clears the path for the next stroke to slide on the workpiece. Back and forth movements in a standing position that guarantees stability determines how best the job is to be cut on the metal. And the blade is to be a little bit tilted upward for the cutting stroke to have free movement, so that the blade, the cutting stroke of the blade, can actually exert the needed pressure that will do the cutting on the job. The teeth of the blade is arranged in a set in order to guarantee that the blade is doing the cutting when it is actually cutting in a forward stroke. We have a situation whereby the blade teeth are arranged in sets all along throughout the length of the blade. The set is just to create opportunity for clearance in the cutting parts of the blade, so that the blade will not get stuck while the blade is moving back and forth in the forward and the backward. So the clearance, meaning that at any point in time when the cutting is done, the width of cutting will always be a little bit larger than the thickness of the cutting points of the blade. So that is the process of axeing. And there are several types of blades that are available. We have all hard, bimetallic, and the one that is not too hard. But we classify blades according to pitch. Pitch is the distance between two successive teeth of the blade. And the application of different types of blades determines which particular blade is going to be selected for a particular application. I said blades are graded according to the pitch, the number of teeth per pitch. Of course, there are some blades that are graded as 18 teeth per pitch. What is 18 teeth per pitch? The distance between two teeth is 25 millimeters. So the number of teeth that are available per pitch of this blade determines the application of that blade. Example is the 18 teeth per pitch. It is for soft material and thick workpiece. When we are considering the 24 teeth per pitch, we make use of that type of blade for steel pipes. In the case of 32 teeth per pitch is already telling us that we have more teeth within the range of a pitch, more teeth. And these are fine blades to cut sheet metals or thin copper pipes. So, a further classification of the number of teeth that are available for the different types of blades is illustrated in my slide. And the particular material type the blades are to cut, ranging between hard and soft material. When I have a material of thickness 3 millimeter, and I want to use a blade that has 32 number of teeth per 25 millimeter pitch, I'm going to use that for hard material. So if I'm to consider a material thickness 3 to 6 millimeter, I must be thinking of, if it's a hard material, a blade of 24 number of teeth per pitch. And if I'm to equally look at a thickness of 6 to 13, I must be thinking of a blade that has 24 number of teeth per 25 millimeter. So if I'm considering a thicker material, like up to 25 millimeter thickness, I'll be looking at a blade, especially if it's a hard material, a blade that has 18 teeth per 25 millimeter gap of the blade. But if it's a soft material that needs too much space to remove the chips that is being cut from the material, I will need relative space. That means there must be low number of teeth per 25 millimeter gap. In that case, we'll be looking at 14 teeth per 25 millimeter gap. This kind of a blade allows space for the material that is being removed. I said we have different types of hacksaw blade material. All hard. All hard is made of hardened high-speed steel. But they last long, but they break easily. Why? Because they are hardened. Their level of hardness is high. They break easily, but they can last longer depending on the skill of the user. A very good skilled user will know how to manipulate the blade in a way that it will not break, even though it's hard. Another type of blade that is still available is the flexible. The flexible is not that hard, but it's equally made of high-speed steel, but with only the teeth hardened. And that is why it is flexible. The body is flexible, but the cutting teeth is hard, because that is where the job is. This one reduces blade life due to the problem of hardening the teeth. The blade can wear easily. While the third type is the bimetallic. The bimetallic combine the features of the all hard and the flexible. Combine the two features together, making it a very good type of hacksaw blade that people can use. When I started the lesson, I discussed about the techniques involved in sawing. As illustrated in my slide, I'm trying to present the posture of a man holding the hacksaw during the cutting. I've mentioned it that the blade must be above the waist, while the standing position must be tight that ensures stability, so that in the back and forth movement of the blade, one will not be able to stagger, and at the same time, the effect of the force will not be felt too much on the shoulder. So, what are the tips involved in hacksawing? We want to look at making sure that one chooses the right blade for the task. That's the very first step. Choosing the right blade for the task. And in the process of mounting the blade on the hacksaw, one must ensure that the cutting points on the blade they are actually facing forward. They are facing away from the user. The cutting points of the blades must face away from the user. They must point away from the user. If that is wrongly mounted, the teeth of the blade will wear quickly. And at the same time, it will not do the cutting as required. The blade will be rubbing on the job, and that will be wearing away the teeth of the blade. We need to equally check whether the blade is properly secured. Mounting the blade at the two secured points and properly tensioned. The blade should not be under tension and it should not be over tension. If it is over tensioned, the blade can break easily in the process of applying them to do the job. And if it is not properly tensioned, the blade will begin to bend when it is being applied for the cutting process. So, and the job to be cut must be firmly secured in the vise. It must be firmly secured in the vise, and we must ensure that sewing is done vigorously in a way to take care of the movement away from the body. One can hit himself or herself with the handle of the blade if you don't create that gap for easy movement of the blade away from the user. Having said this, making use of hacksaw to perform the art of cutting requires some level of safety precautions. And that's why I'm going to talk about the accident prevention regulation, making use of hacksaw. I'm going to start by saying that securely mounted hacksaw will guarantee proper use. But if the hacksaw is not properly secured, or the blade is not properly secured to the frame, that can create some level of hazard to the user. And of course, making use of hacksaw, we need to brush away the chips that is produced with the required tool, not with our hand or finger. And we should not test the sharpness of the blade of the hacksaw by rubbing the finger over the blade. This can inflict cuts on the body or on the finger of the user. And we must ensure that the blade is properly tensioned. A properly tensioned blade will guarantee that the blade does not break in the course of using it. Because if a blade mistakenly break in the course of using, that can enable the user, because if it is in the forward stroke, the user may invariably injure himself with the cut portion of the blade, and that could inflict some level of cut on the user. It is necessary at times to wear safety glasses, and make sure that you do not reach out accidentally to a broken teeth. One needs to be very careful doing this, and in order to work carefully, one must ensure that injury is prevented in the case of blade breakage. And lastly, I must talk about care for hacksaw. Every tool that is being used in the workshop must be properly cared for in order to enjoy best service life from all these tools. One of the things to consider when caring for tools is to make sure that tools are returned back to the shelf after use. And in the course of using them, you must avoid erratic strokes of cut, and too much pressure must not be placed on the tool when you are using it. Having said all this, the art of sewing is a very good process in the workshop, because it is very important that you must cut metal. Metals are always provided in an oversized dimension, and they must be cut to size even before you take them to the machines for normal machining process. By cutting them, especially when you need to take more material out of the metal, processes that could not be handled by filing, you require hacksaw. So art of sewing with hacksaw is a very important task which cannot be pushed aside in the workshop. And it's a very good process that even when you handle it carefully, the art of injury or hazard will be properly minimized. Thank you.